In 2013, Koenigsegg made a decision most engineers would call reckless. They decided to build a 1,500 horsepower hypercar with no gearbox, no backup plan, no precedent. The Regera would prove that 3 electric motors, a hydraulic coupling, and a single fixed ratio could replace every transmission ever made. Instead, coupling temperatures spiked to 140 degrees, costs overran by 30%, a factory fire gutted production, and the board voted to eliminate the only fallback. The story behind this machine is among the insane in modern engineering, and it begins with a blueprint that broke every rule. At the heart of the Regera lies a mechanical layout that defies automotive convention. Where most hypercars rely on a multi-speed transmission to channel power, the Regera's drivetrain is built around a single fixed ratio connection, no shifting, no gears, just direct propulsion from engine to wheels. The backbone of this system is Koenigsegg's 5-liter twin turbocharged V8. It produces around 1,100 horsepower and 1,000 newton-meters of torque, with a red line set at 8,250 revolutions per minute. The engine sits low and rearward, mounted directly ahead of the rear axle. Its compact block and dry sump design chosen to minimize weight and fit within the tight subframe that also houses the rest of the hybrid hardware. Instead of a traditional gearbox, the V8's crankshaft connects to a hydraulic coupling known as the HydraCoup. This custom-built unit acts like a torque bar converter, allowing a degree of slip between the engine and the wheels at low speeds, but locking up for direct drive as speed increases. The HydraCoup is engineered to handle up to 1,500 newton-meters of torque and is cooled by a dedicated oil-to-water heat exchanger, critical for managing the immense heat generated when blending electric and combustion power. The Regera's electric side is just as radical. 3 axial flux motors, 1 mounted on the crankshaft and 2 on the rear axle, work in concert with the V8. The crankshaft motor, rated at about 160 kilowatts and 350 newton meters, serves as both a starter and a source of instant torque at low revolutions per minute. Flanking the differential are 2 more motors, each producing roughly 360 kilowatts and 1,600 newton meters. These rear motors not only add thrust, but also enable torque vectoring, giving the car precise control in corners and under hard acceleration. All 3 motors draw power from a 9.27 kilowatt-hour, 620-volt lithium-ion battery, weighing just 64 kilograms. The battery is mounted low and central within the carbon fiber monocoque, its placement chosen to keep the center of gravity down and preserve chassis rigidity. Capable of discharging up to 500 kilowatts in less than a second, the pack is liquid-cooled, with its own set of cooling loops running alongside those for the hydraulic coupling and motors. This battery not only provides a limited pure electric range, about 50 kilometers under gentle driving, but also supplies the massive bursts of current required for instant acceleration. With the V8, 3 motors and battery all working together, the Regera's total output reaches 1,500 horsepower and 1,800 newton meters of torque. The single-speed final drive, set at a ratio of roughly 2.73 to 1, eliminates the mass and friction of a multi-speed gearbox, allowing the V8's sound and response to reach the rear wheels unfiltered. Every component is packed within a volume that would typically house a conventional dual-clutch transmission, demanding creative solutions for mounting, cooling, and vibration control. The result is a drivetrain that operates more like an electric locomotive than a traditional supercar, blending combustion and electric power seamlessly through the hydraulic coupling. This hardware architecture set the stage for the challenges and breakthroughs that would define the rest of the Regera's story. Raw numbers alone made the Regera's promise feel almost unreal. Koenigsegg set out to build a car that would not just rival the world's fastest, but redefine what a road car could deliver. The headline figure, 1,500 horsepower, came from a blend of combustion and electric muscle. But what mattered to drivers was how that power arrived at the wheels. With no conventional gearbox, the Regera's direct drive system aimed to erase the lag and drama of gear changes. Instead, the V8 engine surge, paired with the instant shove of 3 electric motors, was engineered to create a single, unbroken wave of force from a standstill to well over 400 kilometers per hour. The concept of torque fill was central to this vision. At low speeds, the electric motors delivered their maximum torque instantly, making the car leap forward the moment the accelerator was pressed. As speed built, the V8's turbos spooled up, seamlessly taking over as the main source of thrust. The hydraulic coupling, known as HydraCoup, managed the transition, blending the 2 power sources so the driver never felt a dip or a pause. Early dyno runs showed the effect, a flat torque curve that held steady from 0 up to 3,500 revolutions per minute, then climbed sharply as the V8 came alive. The numbers from those tests were staggering: 1,800 Newton meters of torque, with the battery and motors able to dump up to 500 kilowatts in less than a second. On paper, this meant acceleration that bordered on a breakthrough in performance. Koenigsegg's stated goal was a 0 to 400 and back to 0 kilometers per hour run in under 30 seconds, a full 10 seconds quicker than most rivals could manage. The top speed target, 410 kilometers per hour, put the Regera in the rarest company. But the real breakthrough was in how the car felt on the road. Engineers described the sensation as telepathic. The car responded instantly, with no delay between thought and motion. One senior powertrain engineer likened it to the difference between a fighter jet and a commercial airliner. He said, "You touch the throttle and you are gone. There is no waiting, no shifting. Just a wave that builds and builds." This approach was not just about bragging rights. In the hypercar world, every tenth of a second matters, not just for lap times, but for reputation. Koenigsegg's direct drive architecture promised a new kind of driving experience, one that combined the visceral sound and fury of a twin turbo 5.8 with the relentless, silent force of electric motors. The absence of a gearbox meant less weight, fewer moving parts, and a more direct connection between engine and wheels. It also meant fewer mechanical losses, allowing more of that 1,500 horsepower to reach the pavement. The commercial gamble was just as bold as the technical one. By delivering numbers that eclipsed the established giants, Bugatti, Ferrari, McLaren, Koenigsegg aimed to capture a new breed of customer, one who cared as much about innovation as status. The Regera's spec sheet became its calling card, drawing attention from collectors and performance purists alike. Yet for all the excitement, there was an undercurrent of risk. Achieving seamless torque fill, managing the heat from so much power in such a small space, and ensuring reliability at the limits would test the engineering team at every turn. But in the early days, the promise was clear: a hypercar that could deliver its full potential instantly every time the driver demanded it. Telemetry logs from early Regera prototypes painted a sobering picture. On a series of high-speed track runs, the HydraCoup hydraulic coupling, meant to be the silent mediator between engine and wheels, registered thermal spikes as high as 140 degrees Celsius. The lead engineer, hunched over a bank of monitors, watched the temperature curve climb far beyond the fluid's rated safety margin. Each launch demanded a violent surge of torque, and the coupling's oil-to-water heat exchanger struggled to keep pace. Engineers traced the spike to a specific scenario: rapid repeated acceleration where the slip between engine and rear axle was at its peak. The system's cooling loop, sized for theoretical loads, simply could not dissipate heat fast enough under real-world abuse. But temperature was not the only anomaly. Data from the car's high-speed CAN bus revealed a consistent delay, about 120 milliseconds, between throttle input and the full arrival of torque at the wheels. On paper, this latency was a technical footnote. In practice, it translated to a subtle but perceptible gap. The driver would press the accelerator, and for a fleeting instant, the car would hesitate before unleashing its promised surge. The culprit was a control loop lag between the V8's ECU and the electric motor controllers, compounded by the time it took the hydraulic coupling to transition from slip to lock up. Vibration spectra told a third story. At around 2,500 revolutions per minute, sensors mounted to the rear subframe picked up a sharp 30 Hz resonance, an audible clunk that echoed through the cabin during hard launches. Analysis pointed to a mismatch between the hydraulic piston stroke and the natural frequency of the rear mounting points. The intense pulses of torque, especially when the coupling locked under high load, sent shockwaves through the drivetrain, amplifying any structural weakness. Thermal imaging of the rear motors added to the list of concerns. After just 2 minutes of aggressive driving, infrared scans revealed hot spots at 120 degrees Celsius on the motor housings. The tight packaging in the rear arches choked airflow, and the carbon fiber enclosures, while light and strong, trapped heat close to the windings. Each of these findings, temperature spikes, delayed torque by vibration, and motor hotspots, forced the team to confront the limits of their radical design. The data left no room for optimism. Without immediate and costly intervention, the Regera's promise of seamless, relentless power would remain out of reach. In February 2015, a fire swept through one of Koenigsegg's main production halls. Flames gutted a key assembly area just as the first Regera prototypes were nearing completion. Insurance covered the basic rebuild, but the disruption forced the company to rent temporary space and reroute component shipments, adding months to the schedule and hundreds of thousands of euros to the running bill. Factory staff worked double shifts to recover lost time, but the cost of overtime and rapid retooling hit the budget hard. By early 2016, the finance team flagged a 20 to 30% overrun against the original 3.5 million euros per unit estimate. The chief financial officer, Anders Ronberg, faced a dilemma: either rein in spending or risk burning through the capital set aside for the entire 80-car run. The battery pack, originally sourced from a Swedish startup, was another blow. Delivery delays and thermal failures forced a mid-2017 switch to a German supplier. The new battery was more reliable, but its different dimensions meant the assembly line had to be reconfigured, costing an additional 80,000 euros per car. Each battery pack still cost 1,500 euros more than planned, but at least the warranty risk dropped. Material costs also spiraled. To keep the project afloat, Koenigsegg's leadership authorized a switch from aerospace-grade carbon fiber to a less expensive plain weave variant for non-structural panels. This move saved about 200,000 euros per vehicle, but led to heated arguments between the engineering and finance teams over weight and finish quality. Supplier contracts for turbos and engine control units were renegotiated, shaving 100,000 euros from each build. But by then, the damage was done. The total cost per Regera ballooned to nearly 4.5 million euros. As the board prepared for a tense review, the mood in the finance office was clear. Every technical setback had a price, and the margin for error was gone. March 2016 marked a breaking point behind closed doors for the Regera project. The finance team, led by the chief financial officer Anders Ronberg, presented the latest numbers. Costs had surged nearly 30% above the original 3.5 million euros per car estimate. The boardroom filled with tension as the executive team weighed the future of the program. Christian von Koenigsegg, the founder and chief executive officer, pushed for an all-in commitment to the direct drive system. He argued that abandoning the backup dual-clutch gearbox was the only way to deliver on the car's promise and keep Koenigsegg ahead of its rivals. The chief financial officer saw the risk differently. Without a fallback plan, any failure in the direct drive could threaten the entire production run. The debate circled around one central question. Could they justify pouring more money and resources into a system that so far had delivered as many problems as breakthroughs? The production manager Mats Eriksson added his own concerns about the assembly line. Retooling the jigs for the hydraulic coupling would mean more delays, more overtime, and no margin for error if the new process did not work. After hours of argument, the board reached its decision. The company would approve an extra 15 million euros in research and development, but with a strict mandate, the dual clutch contingency was gone. From that moment, every engineer, technician, and manager was locked onto a single, untested path. The three-level sign-off process, research and development, finance, and the board left no room for reversal. The assembly line would be rebuilt around the direct drive architecture with new fixtures and tools ordered that week. Insurance policies were rewritten to cover KDD-specific failures, further tying the company's fate to the outcome of this gamble. For those in the room, the relief of a clear decision was mixed with a new kind of pressure. The safety net had vanished. Every technical setback from that point forward would carry the weight of the board's ultimatum. There would be no second chance if the direct drive system failed in the next phase of development. 12-hour days became the norm on the Regera project. By mid-2016, powertrain engineers had logged more than 150 hours of overtime each, working late into the night to troubleshoot the HydraCoup's unpredictable behavior. One former engineer remembers the fatigue setting in after weeks of overnight calibration sessions. He describes the moment the team realized the hydraulic coupling's thermal spikes were not a quick fix. We ran the numbers, swapped the fluid, tweaked the code, and still watched the temperature climb past 130 degrees. There was not a single person who was not running on empty. Morale, once buoyed by the promise of building something historic, began to slip. An internal survey, circulated at the height of the crisis, showed confidence in the project's success had dropped from 85% to just 62%. Comments highlighted the relentless pressure and the uncertainty that came with every new technical setback. 2 senior engineers resigned in the months that followed, citing resource constraints and the toll on their personal lives. The strain did not end at the factory gates. For owners, the cost of innovation could be measured in repair bills and downtime. One early customer in Sweden faced a $120,000 bill to replace a failed rear axle electric motor after just 12,000 kilometers. His words capture a sense of disappointment. The roar is unmatched, but the motor problem felt like a betrayal of the brand's promise. For the people who built and bought the Regera, the pursuit of perfection came with real consequences: long nights, missed milestones, and the uneasy knowledge that pushing the limits often means living with the fallout. These stories, hidden behind the headline numbers, reveal the true cost of chasing automotive greatness. On automotive forums and social media, the Regera's reputation became a battleground. Enthusiasts and skeptics dissected every detail, from the direct drive's quirks to the reliability of the hybrid system. A sentiment analysis of major threads in early 2020 showed a 57% positive split, barely a majority, while the rest of the conversation ranged from cautious optimism to outright skepticism. The numbers reflect a community divided, not just by taste, but by expectations of what a hypercar should deliver. In the background, rival manufacturers pressed their own claims to the throne. Rimaac's C2 boasted 1,914 horsepower and a fully electric 4-motor layout pushing the boundaries of acceleration and top speed. Bugatti's La Voiture Noire, with its W16 engine, aimed for 420 km per hour without a hint of electrification. Ferrari's LaFerrari and Porsche's 918 Spider, both earlier entries in the hybrid arms race, offered their own takes on blending combustion and electric power, though with less radical architecture. Each new release forced the conversation back to the Regera. Could a gearless, direct drive system really compete with the established giants? Or was it a technological outlier destined for footnote status? Industry analysts weighed in with a mix of awe and caution. Car and Driver praised the Regera's unfiltered power delivery, while Autocar questioned the sustainability of a boutique engineering effort that ran 30% over budget. On Reddit and Top Gear forums, debates flared over whether Koenigsegg's approach was genius or folly. Some users hailed the KDD as the future. Others warned that the reliability headaches and high service costs were a warning sign. The forum split, 57% positive, became a yardstick for the wider debate, a sign that reputational risk had reached its peak, with no clear resolution in sight. Today, every Regera on the road is a physical gamble, a bet of €2 million that uncompromising vision can outpace failure. As automakers worldwide chase all-electric futures, the Regera's hybrid audacity exposes just how thin the line is between breakthrough and breakdown. Innovation always extracts a price. The question is, in pursuit of speed and status, how much risk are we willing to accept? Let me know your thoughts below.